the total number of numbers from 1000 to 9999 both inclusive that do not have 4 different digits. That do not have 4 different digits. You do like this. We need 4-digit numbers in this case. 4-digit numbers, because 1000 to 9999. Okay. 1000 to 9999 means you have to consider 4 blank places in that case. Now, in this one, how many digits we have? Totally 10 digits. 10 digits are what? 0, 1, 2, 3, so on up to 9. 10 digits are there. So you should not have 0 in this case, of course, you know that. Because if it starts with 0, that becomes a 3-digit number. So it can be filled in 9 different ways. This can be filled in 10 different ways. This can be filled in 10 different ways. This can be filled in 10 different ways. The total number of digits that are available without any restriction, 4-digit digits, 4-digit numbers that are available is 9 into 10 cube is nothing but 9000. Among this, he doesn't want those numbers. He doesn't want those numbers that are all different. Please go through the question. The total number of numbers from 1000 to 9999, both inclusive, that do not have 4 different digits. That do not have 4 different digits. That means having 4 different digits is not needed here. Having 4 different digits is not needed here. That is why we are subtracting it. So anyway, in this case also, 0 should not be there. 0 should not be there. So here it can be filled in 9 different ways. And here 0 can be there. So the remaining numbers will be added with 0, 9. And next will be 8. Next will be 7. Why 8, 7 here? You can understand, because different digits must be there. If one digit is filled here, that should not be used here. If another digit is filled here, that should not be used here. That is why we are reducing the number. 9 into 9 into 8 into 7. So how much is it? It is 9000 minus 9 into 9, 81, 81 into 81 into 81 into 8 7s are 56 is nothing but 4536. Subtract this to get the final answer. It is 4464. Okay, 4464. The simple logic here is we have got the total number of numbers. Total number of numbers, 4 is the total number of numbers, and we have subtracted those numbers that are not needed from the total number. That's what we have got it now. Simple question. Okay, let's go to the next one. The number of numbers between 1 and 10 power 10 which contains the digit 1 is. Which contain the digit 1 is. Similar model. We write all the numbers. And we subtract those numbers that do not contain the digit 1. So if you go to the question, you understand the number of numbers between 1 and 10 power 10 which contain the digit 1. So what we do, we write the total number of numbers first. Then we need those numbers that contain only digit 1. Then we subtract those numbers that are not containing digit 1. So for that purpose, it is simple understanding. Then the number of numbers between 1 and 10 power 10. Number of numbers between 1 and 10 power 10 is if you take the number of digits, how many number of digits are there? Is equal to 10. 0 to 9. 0 to 9 are there. Excluding 1, How many are there? 9 are there. 9 are there. So, if you write the one digit number, let me say, we need that number which is containing 1 only. Containing 1 will be only 1. If you take 2 digit number, it should not start with 0. Okay? Then what happens? You can fill it with 9 different numbers, and this is again with 10. 9 into 10. Among them, we want only those numbers. Among them, we want only those numbers that contain 1. That contain 1. So, what we do, we have to subtract those numbers that are not containing 1. That are not containing 1. Understand the logic carefully. Understand the logic carefully. Of course, in this case also 0 should not be there. It is 9 ways. 9 ways. And there is restriction for 1 also. That means we don't want those numbers that are not containing 1. So, we have to eliminate those numbers that are not containing 1 from this one. So, now I am counting those numbers that are not containing 1. So, 0 eliminated from total number 10. It is 9. But 1 should not also be there. And hence it is 8. And hence it is 8. And in this place, how many do you get now? 0 can be included in this one. 0 can be included in this one. 1 should not be there. 1 should not be there because we are subtracting that. So, 8 into 9. 8 into 9. So, this is minus. So, 9 into 10 minus 8 into 9 is how much? You can see that it is 90 minus 72. 90 minus 72 is nothing but 18 like this. 18 like this. This is the meaning of it. This is the meaning of it. If you going on doing like this, finally, surprisingly what you get on addition, you can see 0 should not be there. So, 9 ways, here 10 ways, here 10 ways, and here 0 should not be there. Here 8 ways, and here 9 ways, here 9 ways. So, 8 into 9 into 9. So, if you simplify this, you will get such a series which gives you the option 10 power 10 minus 9 power 10 minus 1. Okay. So, you proceed like this and understand which should be the answer after adding all this, because 1 digited, 2 digited, and so on like this. If you want 10 power 10 up to the numbers 10 power 10, you can simply understand that. Or simple logic is, because 10 digits are there, it can be formed in 10 power 10 ways, and 1 excluding, 9 digits are there, minus 9 power 10 ways, minus 1 is the answer for that one. You try this try this problem. The number of positive integers less than or equal to 1 lakh, which contain exactly 1, 2, 1, 5 and 1, 7 in its decimal representation. 1, 2 must be there, 1, 5 must be there, 1, 7 must be there. 1, 2, 1, 5, 1, 7 must be there. That means it must start with the 3-digit number. It can be done in 3 factorial different ways. Similarly, here also, first you fill the 4 places. What I was saying, first of all, you have to always fulfill the restriction given. Fulfill the restriction given. 4 blank places, 3 digits, 4p3 into 4p3 into remaining. This blank place can be filled with the remaining digits. How many digits will be there? 7 will be there. Into 7. Into 7. Of course, they may start with 0. They may start with 0. So, 0 should not be there. So minus 3 factorial. What do you understand by that? That's what you are getting here. Minus 3 factorial. 4p3 into 7 minus 3 factorial. Similarly, 5-digit numbers. Here 5p3 into 3 digits are already filled here with 257. How many will be remaining? 7 will be remaining. 7 minus, it should not start with 0. So how many will be remaining? 4 will be remaining. So they can be filled in 4p3 into 7 like that. So you can see that this is plus minus, this is plus minus, this is again you'll get minus for that or the number if you see. Then the positive is less than 1 lakh. 1 lakh means how many digit number is that? 1 lakh 3 plus 2 5 plus 1 6 digit number. Up to 6 digit number you have to write. Then only one thing remains. What else is remaining is if you have 6 digits here and 6 blank places here, 6p3 into of course 7, 0 should not be there, minus same 5p3 into 7. If you add them, these two will be automatically cancelled and this remains. If you simplify that, you will get the answer. Okay, so that's what is the solution for this one. Okay, go to the next one. The total number of numbers of not more than 20 digits that are formed by using the digits 0, 1, 2, 3 and 4 is 0, 1, 2, 3 and 4 is not more than 20 digits that are to be found by using 0, 1, 2, 3 and 4. Understand that. Not more than 20 digits means just now I explained you. It may be 1 digited, it may be 2 digited, it may be 3 digited, so on. It may be 20 digited. 20 numbers. The same procedure, if you fill this and if you find out the summation of this, you'll be getting comfortably the answer. But the correction, or if you want anything in that one, the total number of positive numbers must be given there. Positive numbers. If it is given as positive numbers, then we will avoid 0. If it is given as numbers, then you have to include 0 also. If it is given as total number of positive numbers, the answer will be something like third option, 5 power 20 plus 1. If it is not given, nothing is given, then 0 is also to be considered. Then it is 5 power 20 plus 1. If 0 is to be avoided, it will be 5 power 20. Understand that? 5 power 20. So like that you can do that. Next one is 10 different letters of alphabets are given. 10 different letters of alphabets are given. Words with 5 letters are formed from these given letters. Then the number of words which have at least one letter repeated. This is also an important form of permutation which you will come across in functions also. What is it? If you have n different things, or things are chosen, this choosing of R things may happen in 2 different ways. One without repetition, another one with repetition. So first blank place, these are how many blank places? 1, 2, 3, 4, so on. R minus 1th and rth. First blank place can be filled with n different ways. Second also n different ways with repetition. N, 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 n. How much is it? N power r. Understand that? N power r. If it is without repetition, n minus of r plus 2 into n minus of r plus 1, which is nothing but we derive it to be npr. So what I understand by this, it is nothing but the total number of arrangements without any restriction, or you can call it as the total number of arrangements with repetition. These are the total number of arrangements without repetition. But we want at least one repetition. Understand this carefully. At least one repetition means what? We don't want those arrangements without repetition. These are without repetition. We don't want them. So what we do, we subtract the total, we subtract this from the total, n power r minus npr. Simple logic. N power r minus npr. So the number of arrangements of n dissimilar things by taking r at a time with at least one repetition is equal to n power r minus npr. How do you apply this in functions? That's what I'm telling you now. The number of many to one functions. What is npr? Without repetition. What is the definition for one function? One function is that function, different elements in the domain will have different images. That's nothing but npr. And what is n power r? It gives you the total number of functions. So if you want to convert this formula to functions, here it gives you, for your better understanding, I'll place it in this way. F maps A to B, and it gives you n of A, it gives you n of B. Number of functions, total number of functions is nothing but n of B whole power n of A. This is with repetition. It's nothing but n of B whole power n of A. That is nothing but n power r in this case. And minus without repetition is nothing but one functions, number of one functions. It is nothing but n of B, n of A. So this gives you the total number of functions. This gives you number of one functions. So we don't want number of one functions. Then what all the functions you get will be always many to one functions. So this is a formula for many to one functions. So that's what is the next problem in this problem is to be applied is what? How many alphabets are given there? 10 different letters of alphabet are given. 10 different letters of alphabet are given. Words with 5 letters are formed from those given letters. What does it mean? 5 different places are to be chosen. How many alphabets are there? 10 are there. So they can be filled in 10 into 10 into 10 into 10 into 10. Without knowing the formula also, you can do like this. Minus. At least one repetition must be there. Means we don't want those arrangements without repetition. That is why what I'm doing, without repetition case, I'm subtracting. First blank place filled with 10 different ways. Without repetition, 9. Without repetition, 8, 7, 6, like this. It is 10 power 5 minus, you multiply this to get the final result. It is 10 into 9 8s are 72 into 42. 10 power 5 is 1 lakh minus, it is this is 30240 is, now if you subtract this, the answer you'll get is 69,760 is the correct answer. So with at least one repetition, formula please, at least one repetition, formula please, n power r minus npr. This is an important formula, n power r minus npr. Okay, let's go to the next one. The letters of the word cricket are permuted in all possible ways and the words thus formed are rearranged as in a dictionary. The rank of the word cricket is. You all know how to find out the rank. You all know how to find out the rank. That lengthy method which we use in IPE is very much known to you. I'll teach you a shortcut now so that you will feel comfortable in working out this model problems. So let me take a simple word first to without repetition of letters, and I'll explain you how to find the rank. If you take mother, if you want to know the rank of this word mother, what is that rank here? Here our alphabets are only 6. English alphabet are 26. So all those 26 are arranged in the form of a dictionary. If you refer to the dictionary, then A, B, C, D, E, F up to Z, first alphabet. Second alphabet also arranged from A to Z. Third alphabet also arranged from A to Z. Like that, all the words are arranged in the form of a dictionary. But in our dictionary, in this problem, only 6 alphabets are there. These 6 alphabets are arranged differently. Like what? How many ways they can be arranged? In 6 factorial different ways they can be arranged. 6 factorial means it is nothing but 720. That is, by arranging them, you will not be getting 720 different words. You will be getting 720 different arrangements. 720 different arrangements. All these 720 different arrangements are arranged in the form of a dictionary. Then in such dictionary, what should be the position of mother? Where does that mother ranks? That's what we need. So you all know the procedure, the lengthy procedure like the subject to method, you know, but I am teaching you now the shortcut. In the shortcut, what you have to do here, give the alphabetical numbering. Give alphabetical numbering. What is it? First E, 1, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. I have given alphabetical numbering 1, 2, 3, 4, R, S, T. That's what it is. Okay. After this, what you have to do, count the number of numbers that are less than 3, only right side to it. Count the number of numbers that are less than 3, only right side to it. This is not less, this is not less, this is less, this is less. How many are there? 2 are there. Write that number. Count the number of numbers that are less than 4, only right side to it. Only right side to it. 2 are there. Only right side to it. 3 are there. Only right side to it. 1 is there. Only right side to it. 0 is there. Only right side to it. 0 is there. That's what I have written. Okay. Now start writing from 0 factorial from right to left. 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. Okay. Now multiply 2 into 5 factorial. Just for your understanding, I am doing that. Otherwise, we'll mind calculation. You can write directly that. Plus 2 into 4 factorial. Plus 3 into 3 factorial. Plus 1 into 2 factorial. Plus 0 plus 0. These are the different arrangements before mother. Before mother. But if you want to include mother also, plus 1. Plus 1. So what should it be now? It is 5 factorial into 2. It is 120 into 2. It is 240 plus 4 factorial into 2. It is 24 into 2. 48 plus 6 into 3. 18 plus 1 into 2 factorial. 2 plus 1. So how much is it? 3 plus 8. 11. 11 plus 8. 19. And it is 5, 9, 10. And it is 309. 309 is the rank of the word mother. This is a short form of doing it. Okay. Now, then you may think, if because all the alphabets are different, it is easy for us. But what happens if the repetition occurs? Same method we apply. Same method we apply. You note down this. It will be comfortable to you. And anyway, I'll discuss with repetition now. With repetition, simple thing. Simple thing. With repetition means the digits will also be repeated. When the repetition takes place, what we do, we divide with its factorial. We divide with its factorial. So we will take down the question now. In this one, the word given is cricket. Cricket. Let us find out the rank for cricket now. It is now. Let us give the alphabetical numbering. This is 1, 1. C. C is 1. Next, 2, E. I, 3. IJK, 4. RST, 5, 6. So, 2 ones are here. 2 ones are here. Then, less than 1, nothing is there. But for your better understanding, what I tell you, take the repetitions, including this number, 0 by 2 factorial, you must write perfectly. Of course, its value is 0. Of course, its value is 0. Sometimes it may not be. That is why you should not forget that. 0 by 2 factorial. 5, less than 5, only right side to it. 1, 2, 3, 4. Less than 3, only right side to it. 1, 2. Less than 1, only right side to it. 0. Less than 4, only right side to it. 1, 0, 0. That's what your understanding must be. Now 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial. 0, 5 factorial, 120 into 4, 480, plus 24 into 2, 48, 0, plus 2, all this 0, plus 1. So it is 50, it is 50 plus 480, 530, it should be 531 is the rank for the cricket. If you write in the lengthy way, it will take more and more time. If you practice it in this way, it will be very easy for you. Okay, so the rank of cricket there is 531. Okay, so if you take a simple word which you have already done is mirror, practice such type of words wherein the repetition is there. There are 3 letters repeated here. Let me write this. Within 1 minute we will do this. What is the first IJK element? I is 1, 2, O, 4, 4, 4. Correct or not? So less than 2, only 1 is there. And how many repetitions are there? 3 factorial. 3 repetitions are there. Less than 1, 0, but 3 factorial. Less than 4, only 1, but 3 repetitions. 1 by 3 factorial. Less than 4, only 1, but 2 repetitions. 2 factorial. Less than 3, nothing. Less than 4, nothing. 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. So what should it be now? It is 5 factorial upon 3 factorial means it's 20. It is 0. It is 1. It is 1, 0, 0, plus 1. What for plus 1? Mirror plus 1. How much is it? 22 plus 1. 23 is the answer. In the short form, you can find out the rank of the word like this in a simple way. Okay? Now, if you see the next one, if all permutations of the letters of the word again are arranged as in a dictionary, then 50th word is, you can apply, why I have taken this problem immediately, you can apply even the same shortcut for the options. You can apply the same shortcut for the options and you can find out which one will be the 50th word. That will be simple. But if you see again, let us not forget the method. Again, for this one, alphabetical arrangement will be A-A-G-I-N. A-A-G-I-N. Let us start with A now. 1, 2, 3, 4. This can be arranged in 4 factorial different ways. A fixed here. 4 letters can be arranged in 4 factorial different ways, which gives you 24. Right with G. G again 4. But 4 factorial upon 2 A's will come. 2 factorial, it is nothing but 12. I. 1, 2, 3, 4. It is again 4 factorial upon 2 factorial, it is again 12. Because our target is 50th word, by now you might have understood we have reached 48. 24 plus 24, 48 we have reached. Now let us go for N now. You can write the words directly now. Let's come to this one. N-A-A-G-I. This is 1. This is 1. One arrangement I have written directly. Because it is 49, I'll be knowing. Now, N-A-A. After G, I comes because N is already there. I, then G comes. This is 1. This is 1. This is 50th. So 50th word is N-A-A-I-G. N-A-A-I-G like that. So in this way, it is direct method. Even if you practice it properly, you can do like this also very easily. But if you practice that shortcut, you can write even the bigger words also very easily. Okay. So this is about the finding the rank and all. So you can work out more and more problems in permutations, and we'll continue in the next session the combined problems of permutations and as well combinations in the next session.